Hello and welcome to the applications section of the National 5 video tutorials. Today we're going to look at sine rule. So sine rule is a method of finding missing sides or missing angles in a triangle. What you need to be able to do when using sine rule is pair up two sets of information across the triangle. So you should have a side and a corresponding angle. For our triangle this is 5 meters and 68 degrees. And you should have either a side or an angle that corresponds with an unknown value. So in this case we've got 50 degrees paired with x meters. We don't know what x meters is yet. Okay, we're finding a side for this question, so we're going to start with our sine rule with our sides on top. So A over sine A equals B over sine B equals C over sine C. So our A, B and C on the top are all side lengths. Our sine A, our sine B and our sine C are all sines of angles. We're going to now substitute in the information that we've got in the diagram. So here we have our unknown variable with our 50 degrees. So that's A over sine A becomes x over sine 50. And then B is going to be 5 meters and sine B is going to be sine 68. So we've got 5 over sine 68. Okay, so next step we need to rearrange this. So to get the sine 50 off the bottom of this fraction, we are going to multiply both sides of the equal sign by sine 50, and our answer is going to be x is equal to 5 sine 50s over sine 68. And then at this point we can just put that into a calculator. If we type in 5 times sine 50 divided by sine 68, we get a value of 4.13 meters. And that's our final answer. Here are 4 examples for you to try using that exact same method. Find each of the missing sides, make sure you get your units right because they change from triangle to triangle. And pause the video now because I'll be uploading the answers in just a second. Okay, so your answers are as follows. For the first triangle, 16.4 centimeters. For your second triangle, 5.38 meters. For your third triangle, 54.43 centimeters. And for your bottom triangle, that's 7.54 millimeters. To find a missing angle using sine rule, it's exactly the same process except for the formula is swapped over. So instead of the sine A being on the bottom, it is now on the top of our fraction. So sine A over A is equal to sine B over B is equal to sine C over C. Okay, so here's the information we're going to put in first. We're going with our unknown variable and its corresponding side first. So we've got sine x degrees over 5 is equal to, we've got our known angle and our known side, so that's going to be sine 31 degrees on the top and 2.8 centimeters on the bottom. Okay, same as last time, we need to multiply by the bottom of this fraction here on both sides in order to remove it. So we end up with sine x on its own is equal to 5 times sine 31 all divided by 2.8. This is equal to 0.919 ... big long decimal number. And to find x, our angle, what we need to do is we need to keep that big long decimal number in our calculator, and then we're going to do sine to the minus 1, or the inverse sine of that big long number. Our final answer for that one is 66.88 degrees. Okay, so very similar. There's a little extra step at the end. When you get a big long decimal number, you have to sine inverse it in order to find your angle, but pretty much the same process as we just learned there. So here are 4 examples for you to try out. Remember, again, lay out your working, find your decimal, don't do any rounding, put it into your calculator and find your angle. Okay, pause the video now. I'm going to show you the answers in just a couple of seconds. So here we go. For your first triangle, you should have an angle of 52.81 degrees. For your second triangle, you should have 13.4 degrees. For your third triangle, you should have 130.8 degrees. And for your last triangle, you should have 44.35 degrees. Finally, if you'd like to try your hand at a few exam-style questions using sine rule, here are your links to the SQA past papers. Remember, all the SQA past papers can be downloaded for free from the SQA website. Thanks for watching and keep studying hard.